Hello students, this is Swati, mathematics teacher. This video for 10 state and 10 CBSE student. Today we are discussing about the chapter is chapter number 1, real number. In this real number, weightage of 4 marks for 10 state 2 students, 6 marks for 10 CBSE student. This chapter is very easy and scoreable chapter. Point of your examination, important topic of this chapter is basic definition of real number, fundamental theorem of arithmetic, SCF, LCM, prime number and prime factorization. Important are basic definitions of this chapter. Real number. Real number is always represented by capital letter R, and union of rational and irrational numbers are called real numbers. And second one is integers. Integer is represented by capital letter I, and all numbers from -2, -1, 0, 1, 2, 3, etc. And rational numbers. Rational number always represented by capital letter Q, and which number in the form of P by Q and Q not equal to 0. P and Q are belongs to integer. In a rational number, all integer can be expressed as a rational number. For example, 5 by 1, -3 by 1. And decimal expansion of rational number, terminating or non-terminating recurring. In terminating and non-terminating, we are studying 9th standard. Irrational number, which number or real number which cannot be expressed in the form of P by Q, Q not equal to 0, is called irrational number. For example, √7, √5, √2, √11, like that. And fifth one is natural number, represented by capital N. Counting numbers is called natural number. For example, 1, 2, 3, 4 without 0. Sixth one is whole number, is always represented by W. 0 along with all natural number is called a whole number. And seventh one is even number, natural number of the form of 2n. For example, 2, 4, 6, 8, 10, 12, like that. Eighth one is odd number. Odd number is counting number, 1, 2, 3, 5, 7, like that. Means 2n plus 1. In this chapter, important prime numbers. A prime number is a whole number greater than 1 whose only factors are 1 and itself is called a prime number. For example, 2, 3, 5, 7, 9, 11, like that. And composite number, it can be divided exactly by number other than 1 and itself. And is composite number have more than 2 factor is called a composite number. Important note is there, one is either prime nor a composite number, not saying exactly one is a prime or one is a compact composite number, is either prime nor composite number. For your better understanding of real number, see this chart clearly. So real number is union of rational and irrational number. In a rational number, non-integer rational number, integer. In the integer, negative number, whole number 0 and natural number. So dear student, come to your chapter, very important statement, fundamental theorem of arithmetic. This is very important. Every composite number can be expressed as a product of prime, and this expression is unique apart from the order in which they appear. This statement important for your examination. Sometimes ask statement for 1 marks. So what is the fundamental theorem of arithmetic? So before going to FTA theorem, better understand prime factorization method. So what is prime factorization method? So name is itself saying prime numbers. We using prime numbers for factorization method. So what is this method? This method, suppose we have to see that 1092 number, this number is divisible by 2. So we observe that prime factorization method. What is prime factorization method? This method, the process of break down a number into its prime numbers. Suppose we take any one number, only prime numbers can divide this number. Only prime numbers is called a prime factorization method. So suppose we have to take number 306. We observe that last number is 6, so it's divided by 2. So we can take the 306 number. So what is prime number? 2357. So 2 ones are 2, remainder is 1, then is become 10, then 2 5s are 10, 2 3s are 6. We observe that in a last number is 3, is not divided by 2, so we can take 3 5s are 15, 3 1s are 3, so we got 51. We observe that last number is 1, this is also not divided by 2, so we take 3 1s are 3, 3 17. 17 is a prime number, is only divided by 1 and itself, so we can divide by only 17 and itself. Then write the prime factor of 306. So 306 equal to, what is the factor? 2 into 3 into 3 into 17. So which number is repeated twice or thrice, we can write in the form of power. So 3 square into 17 into 1. This is the prime factor or prime factorization method. Can you take another example for better understanding of prime factorization method? So second example is 78. So last digit is 8, so we can divide this number in 2. 2 3s are 6, remainder 1, so it's become 18, 2 9s are 18. So last number is 9, we cannot divide it by 2, divisible by 2, so 13 ones are 13. So what is the prime factor of number 78? 2 into 3 into 13 into 1. 2 into 3 into 13 into 1. This is the prime factorization method. Now we discuss FTA theorem, fundamental theorem of arithmetic. Every composite number can be expressed as a product of prime, and this expression is unique apart from the order in which they appear. So what is composite number? Every composite number. So what is composite number? Which number have more than 2 factor is called a composite number. For example, 4, 6, 8, etc. So example, take 4. So 4 is divisible by 2. Yes, 2 ones are 2 2s are. So what is the factor of 4? 2 into 2 into 1. Any number is repeated is is in the form of square or 2 square 1. So in this factor 2 also prime, and 1 is a prime or composite number. So we can write this 2 into 2 into 1 in the form of 1 into 2 into 2, but the order or position of the number is changed. So another example is take 12. 12 6 12 3s 3 1s. We can observe that is prime factorization method. What is the factor of this 12 number? 2 into 2 into 3. We observe that 2 and 2 3. There are 3 factors also a prime number, and observe that only this prime number is unique. So we can change order or position, but this is the unique method for solving. Suppose 12 can divided by 4 into 3 or 3 into 4, but 4 is not a prime number. So every composite number can be expressed as a product of prime. So we observe that FTA theorem say every composite number can be expressed as a product of prime. We observe that only a product of prime. 4 3s are 12, but 4 is not a prime number, so we can't write that 12 is factor of 4 and 3, and this expression is unique. Yes, this expression is unique apart from the order in which they appear. Apart from the order means position will be changed. So this is the FTA theorem. So method of finding SCF. So what is SCF? Highest common factor, but definition of HCF is product of the smallest power of each common prime factor. SCF and LCM is very important topic in these chapters. So we memorize that product of the smallest number. We note that smallest power of smallest power of each common prime factor. So this is very important. And method of finding LCM, least common multiple, product of the greatest power of each prime factor. Difference between the SCF and LCM is little bit. SCF is smallest power of each common factor, but LCM is greatest power of each prime factor. There is a lot of difference, so don't confuse, dear students. So LCM is product of the greatest power of each prime factors. So then we take example for finding SCF and LCM. Find SCF and LCM. So first one is we take 6 and 20. Find out SCF and LCM of 6 and 20. We take 6, 2 3s are 3 1s are. So again 20, 2 10s are, 2 5s are, and 5 1s are. So we can write both factors of 6. First one, write the factor of 6. What are the factor? 2 3 1, and factor of 20 is 2 2 5. So next, find out the SCF of 6 and 20. SCF 6 and 20 equal to, what is the definition of SCF? Smallest power of each common factor. We observe that in these two numbers, what are the common term? 2 only. So we take 2. And LCM of 6 and 20. So we observe that LCM of 6 and 20, greatest power. Which one is highest? In the both number we have 2. But factor of 6 is only 2 power 1. But factor of 20, 2 square. So what is LCM? 2 square into 3 into 5. 2 2s are 4, 4 into 3 into 5. 4 into 3 into 5 what? 4 3s are 12, 12 5s are 60. LCM of 6 and 20 is 4 plus 3 into 5. 4 5s are 12, 12 5s are 60. So LCM of 6 and 20 is 60. This is the method of finding SCF and LCM. Important formula of this chapter: SCF and LCM. SCF into LCM equal to A into B. In this question asks sometimes multiple choice question, 1 marks questions also, and there is a problem of this formula, 2 marks question. Is very important formula. SCF into LCM equal to product of two number, or SCF into LCM equal to A into B. Dear student, definitions and key points and formulas all are completed. So we can go exercise problems. Exercise 1.1. First question, express each number as a product of its prime factors. So we neatly read question. So what we has a prime factor. Express each number as a product of its prime factor. So we only find out prime numbers. Using the prime numbers we have to solve the factorization method. So first one is exercise 1.1. So first question 140. First question 140. 140. Find out 2, 2 sevens are 0, 2 3s are 6, and 1 is remainder 10. 2 5s are 10. In last number is 5, last digit is 5. We cannot divide it by 2. So we choose 3 or 5. So what is the factor of 140? 2 into 2 into 5. Any number is repeated, we can write in the power form. 2 square into 5 into 7. This is the factor of 140. These questions ask for 1 marks. So second one is 156. So 2 sevens are 14, 1 is remainder 16, 2 3s are 6, and 2 9s are 18. So last digit is 9 not divided by 2. We can take 3 13s are 13 is a prime number. So we can take 13 itself. 13 ones are 13. What are the factor? We can write directly 2 square into 3 into 13. This is the exercise 1.1 first question. And second question is So find out the SCF and LCM and verify also ask. So dear student, first we have to find out LCM and SCF of 26 and 91. We can solve both at a time or separately also. So first we have to write 26, 2 ones are 2 threes are 13 is a prime number, is only divided by 13 itself. What is the factor? 2 into 13. Then we can take 91. 91 is, we observe that last digit is 1. We cannot divide it by 2. So 7 ones are 7, 2 is remainder, 7 threes are 21 and 13 ones are 13. What is the factor? 7 into 13. So find out SCF of 26 and 91. What is the definition of SCF? Smallest power of each common factor. What is the common factor of this number? 13. LCM 26 and 91. So we can greatest power of each factor. We can write each factor, but first preference of highest power. In these two numbers we don't have any highest power, because 2 power 1, 13 power 1, 7 and 13 itself. So 2 into 13 into 7, what are multiplication? 182. So then another question is as verify SCF into LCM equal to product of two numbers. Important formula. What is the LCM? 182, SCF 13, and we multiply 26 and 91. So what are we get? 2366. So LHS and RHS are equal. So the equation is verified. What is second one? So second one question is 5, 10 and 92. 5, 10 and 92. This is the second question. Five, 10 and 92 we find out separately and at a time both also. So 5, 10. So last digit is 0. So can you divide 2? 2 2s are 4, 2 5s are 10, again 2 5s are 10. So we observe the 225, last digit 5 we cannot divide it by 2. So we choose 3 or 5. So check that 3 ಇಂದ ಆಗುತ್ತಾ ಆಗಲ್ವಾ ಅಂತ ಚೆಕ್ ಮಾಡಿ ದೆನ್ 5 ಹೋಗಿ. ಸೊ ದೆನ್ 5 5 are 25, 5 1s are 5. 51 is a prime number. Prime number is always divisible by itself or 1. So we can choose 51 also or other. So student 255 is divisible by 3 also. So 5, 10, 2 2s are 4, 1 is remainder. So 1 is remainder, 2 5s are 10 and 2 again 1 is remainder, 2 5s are 10. Then 255 is divisible by 3 also, because 3 8s are 24 and 1 is remainder 15. 3 5s are 55 and again we can divide it by 5 also. So 5 1s are 5, 3 is remainder, 3 7s are 15 and 17 is a prime number divisible by itself. So factor of 5 10 and choose 92. 2 4s are 8, 2 4s are 8, 1 is remainder, 2 6s are 12 and 2 2s are 2 3s are again 23 is a prime number, is divisible by itself. 23 only, 23 ones are 23, and write the factor of these two numbers. So factor of 5 10 is 2 into 3 into 5 into 17 and factor of 92 is 2 into 2 into 23. So we observe that 2 is repeated twice, so we can write 2 square into 23. Find out SCF. Which one is common factor in both factor? 2 is the common, 2 itself, no other common number is there. LCM of 5 10 and 92 is, we observe that which one is the greatest power? 2 square is highest power, and each factor we can write each factor 3 into 5 into 23 into 17. So 2 is not write twice, 2 square is itself. then multiply. We can multiply LCM 23,460 and then verify LCM into SCF equal to A into B. What is the LCM? 23,460 and SCF is 2. We can multiply 510 and 92. So we got 46,920. So HCF, LHS and RHS are equal. And third problem is 336 and 54. 54 in same method, very easy method, 336. So we can divide it by 2 ones, 1 is remainder, 2 6 are 12, again 1 is remainder, 2 8 is 16, and then again 2 8 the 2 4s, then again 84, 2 2s are 2 1s, 21 is a prime, itself is divide. Or 7 also is there, 7 3s are 21, or no, sorry 3 7s are 21, 3 7s are 21, 7 1s are 7. Then we divide 54, 2 2s are 4, 2 7s are 14, and again 3 7s are 3 9s are 27, 3 3s are 9, 3 1s are 3. So can we write again factor of these two numbers and find out the SCF, LCM and verify. So what is the factor of LCM is, we can write directly, LCM is 3029, SCF is 6. So verify that LCM into SCF equal to A into B. So LCM is 84 and SCF is total multiplication of RHS equal to LHS. Then so we observe that 336 equal to 2 into 2 into 2 into 2 into 7 into 3 into 1. So LCM verification is important, always LCM into SCF, RHS equal to LHS is must and should verification is both sides are equal, rather than your multiplication is wrong or prime factorization is wrong. So in third main, find the LCM and SCF of the following integer by applying prime factorization method. So we can use only prime number for the factorization method. So what is the number? 12, 15 and 21. There is a 3 number is there. First one is 12, second one is 15 and third number is 21. We can find out factorization or factor for is 3 numbers at a time or separately. We not comfortable, we find out separately because sometimes SCF is confused. In a third main, there are 3 questions is there. In these 3 questions I can solve completely, and this is also good questions and important question for your examination. There is a ask for 2 marks question only. So first question is in third main, first question is, what is the first question? 12, 15 and 21. So can I find factors for this 12 number 12, 2 6 2 3 3 1 is very easy. Next number is 15. 15 is not divisible by 2, we can take 3 5 5 1. Next 21 is a prime number, divisible by itself only. Students, no, sorry that, so 3 7s 7 1s. 21 is not a prime number, sorry. LCM, what is the LCM of this number? Greatest power of each factor. So what is the greatest power? 2 square into 3 into 5 into 7. So 3 into 2 square into 5 into, what is the SCF? Common factor is, what is this? 3. So 3 is the factor. SCF is 3, LCM is 420. Can I multiply 3 into 4 into 5 into 7? So what is the third main second question? Dear student, understand that 17, 23 and 29. So 17 17 is a prime number divisible by itself. 23 also a prime number divisible by itself. Dear student, don't mistake that. 29 also a prime number, so divisible by itself. This question is very simple and very easy. What is the LCM? 17 into 23 into 29, greatest power of each factor. So multiply 17 into 23 into 29, 11339. What is the SCF? Only 1. Not write 0, only SCF is 1. Then third question is 8, 9 and 25. So find out factor of 8, 2 4s, 2 2s, 2 1s. Very easy. And 9. 9, 3 3s, 3 1s. 25 is divisible by 5, 5 5s, 5 1s. Can I write directly LCM and SCF? Yes, LCM is 2 cube, 3 square into 5 square. So what is 2 cube? 2 cube means 8. 8 into 9 into 25. 8 into 9 into 5 square means 25. 5 into 5, 5 is a 25. Then what is the SCF? What is the common term of these three number? So SCF is, there is no common, only one is the SCF. Don't write 0. We lose your marks. So SCF is 1. Because 1 also a factor of numbers. So then exercise 4th main, given that SCF equal to 9 and SCF equal to 9, find out LCM. So this is important question. Using the formula of SCF into LCM equal to product of two number, or LCM into SCF equal to A into B. LCM equal to A into B. This formula is important for your point of your board examination. So what is the SCF given? 9. 9 into, what is A? 306. What is B? 657. So LCM, we can what are find out LCM equal to 306 into 657. Multiply that 201042 divided by 9. Can I divide that? 2 2s are 18, sorry, 9 2s are 18, 2 is remainder. So again 21 is there, again 9 2s are 18, 3 is remainder, again 3 is remainder means 30. So what we get? 223338. 223338. This is the LCM. This is the LCM. So this question is completed. So next exercise 1.1. So we observe that SCF into LCM equal to product of this two given number, 9 into. So fifth question, check whether 6 power n can end with the digit 0 for any natural number. This question is important. Sometimes ask 2 marks also or 3 marks also. This question is important question. 6 power n end with 0 for any natural number. So what is 6 power n? N belongs to natural number. We can write n equal to 1, 2, 3. Can write n equal to 1, 2, 3. Like that. So put 6 power 1 equal to 6. What is 6 square? 6 6 is 36. What is 6 power 3? 216. And what is 6 power 4? 1296. So we observe that every last digit number is 6, not a 0. So how to prove that? So we can prove that what is the last digit 0. What are the numbers are come? So what is the factor of 6? 6 is always divisible by, so 2 into 3. Only 2 and 3 are the factors of this number 6 or 6 power n. So what is a factor of 36? So 2 9s, 3 3s, 3 1s. So what 2 square into 3 square. What is the factor of 216? 2 power n into 3 power m. What is the factor of 6 power 4? Exactly 2 power n into 3 power m. So what can we prove? 6 power n. Check whether 6 power n is end with the 0. end with 0 digit. What are the numbers? 10. 10 power 1, 10. 10 power 2, 100. 10 power 2, 100. 10 cube, 1000. So what are the factor of 10? So you observe that last digit is end with 0. So 10 power 1 is end with 0, 10 square is end with 0, 10 cube is end with 0, and find out the factor of 10, 100, 1000. 2 into 5. This is also 2 power 2 square and 5 square. Then what is the factor of 1000? 2 power n into 5 power n. We observe that factor of 6 and 10. Observe that factor of 6 and 10. Factor of 6 is 2 into 3. But factor of 10 is 2 into 5. So we can easily say that 6 power n cannot end with 0 because factor is any number end with 0. We have a factor 2 into 5, but in 6 power n only factor 2 and 3. So there is a lot of difference. So 6 power n does not containing prime number 5. So clearly say that any natural number 6 power n not divisible by 5, and we cannot end with 0 for any natural number. So next, sixth one question is explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 sure composite number. This is the important question. Sometimes asked last year also asked this question. So how to solve this? Very easy method. For you using prime factorization method we can solve that. So write first one. What is the question? I solve only one question. Another one also same pattern. We can solve itself solve that one. So what is the question? 7 into 11 into 13 plus 13. So we take common 13. Which number is repeated? We take common that number. So then multiply 7 into 11 into 1. 7 11 is 77. 77 into 1 77. 77 plus 1 78. Then find out factors of number 78. Factor of number 78. What we get? Find out 78. 2 3s are 6. 2 9s are 18. So then last digit is 9. We cannot divide it by 2. So is divisible by 3. So 3 1s are 3 3 is 13 is a prime number divisible by itself. What are the factors? 2 into 3 into 13. So what is composite number? Composite number is more than 2 factor. Which number have more than 2 factor is called a composite number. What are the factor of 7 into 11 into 13 plus 13 number? So 2 into 3 into 13 into 13. There are a 4 factor. So we can say that 7 into 11 into 13 plus 13 is a composite number. And another question is there. You can solve. Please solve this problem itself. So then what are the 7th problem? There is a circular path around a sports field. Sonika take 18 minutes to drive 1 round of the field. Will Ravi take 12 minutes for the same? Suppose they both start at the same point at same time and go in the same direction. After how many minutes will they meet again at the starting point? So dear student, we observe that there is a circular path. There is a circular path. This path is a sports field. So Sonia and Ravi running this field. Sonia take complete 1 round in 18 minutes. Ravi take complete 1 round for 12 minutes. Suppose if both Sonia and Ravi in the same point, in the same field, in the same time, in the same direction. Suppose Sonia and Ravi both same point start a running 1 round, complete round. In same point we meet again. In which time? In how much time will both take. So both take, let us take LCM of 18 and 12, because Sonia completed in 18 minutes and Ravi completed in 12 minutes. So let's take LCM for both 12 and 18. What is the factor of 18? 2 into 3 square. What is the factor of 12? 2 square into 4. What is the LCM of this number? What is the LCM of, what is the definition of LCM? Greatest power of each factor. So 4 into 9. Greatest factor is 2 square and 3 square. 2 square means 4. 3 square is 9. 36 minutes we take. Both are take 36 minutes. Then exercise 1.2, prove that root 5 is irrational number. This part question is very important question. This question is as 3 marks compulsory question for your board examination. So prove that root 5 is irrational number. For this proof, we take contradiction method for solving this theorem, because what is contradiction method? Contradiction means prove. What are the question asked? Prove that root 5 is irrational number. What are the contradiction method? Which means opposite. What are the opposite of irrational number? Is nothing but rational. So we take contradiction method. Let us assume that proof. Let us, very important question. This is the compulsory questions for your point of your examinations. Let us assume that we only assumption. There is a assumption is there. Take contradiction method, write step by step neatly. Dear students, very important question. Write step by step neatly. Let us assume that root 5 is a rational number. What is rational number? Which number in the form of p by q and q not equal to 0. In this theorem, using p and q are prime number, co-prime integer or co-prime number. What is co-prime integer? Co-prime integer is nothing but a and b is divisible by only number 1, not same number, only divisible by 1. So this is very important, where a and b is a co-prime integer or co-prime number and b not equal to 0. Then second step is we take squaring on both sides. Take squaring on both sides. So root 5 whole square equal to a square by b square. Then square and square root get cancelled. 5 equal to a square by b square. Then take b square other side. 5 into b square equal to a square. Then take 5 other side. B square equal to a square by 5 square. So observe that b square equal to a square by 5. What is say that 5 is a is divisible by 5 and also a square is divisible by 5. So we take equation 1, a square is divisible by 5 and also so a is divisible by 5. A is divisible by 5. We can agree that a square is divisible by 5. So a is also divisible by 5. So take one example, a equal to 5. Suppose a equal to 5. 5 is divisible by 5 and 5 square means 5 is a 25 is divisible by 5. Can agree that this statement? Yes, a square is divisible by 5 and also a is also a divisible by 5. Then theorem is not, proof is not completed. This is only one part is completed, another part is there. Take a equal to 5k. So k is a integer. K is integer. Take square on both sides. A square equal to 5 square into k square. So what is a square? Observe that this equation 5b square equal to a square. Substitute that 5b square equal to 5 square into k square. We cancel 5 and 5 also. B square equal to, so take 5 or either side. So b square by 5 equal to k square. We observe that this is the equation 2. which one is b square by 5 equal to k square. So observe that b square is divisible by 5 and also b is divisible by 5. We agree that? Yes, we agree. B also divisible by 5. B also divisible by 5. So but what is our assumption? What is our consideration? Let us assume that root 5 is rational number. What is rational? Root 5 equal to a by b. But what are a by b? Co-prime integer. What is co-prime integer? Is only divisible by 1 but is divisible by 5. So our assumption is wrong. Our assumption is wrong. So hence root 5 is irrational number. So I will again say, dear student, this step by step procedure is very much important. This question is 3 marks question. One note that. Second question is, prove that 3 plus 2 into root 5 is a irrational number. This question is sometimes asked 2 marks only. So but very easy question, not a lengthy. So next one, second question, 3 plus 2 root 5 is a irrational number. So same, we take contradiction method. Let us assume that 3 plus 2 5 is a rational number. ಪ್ರತಿ ಸಲ ಕೂಡ ನೀವು ಇದನ್ನೇ ಬರೀತಾ ಹೋಗಬೇಕು. ಪ್ರತಿಯೊಂದು ಸ್ಟೇಟ್ಮೆಂಟ್ ಏನು ಬರೆದ್ರೆ ಅದೆಲ್ಲ ಕಂಪಲ್ಸರಿ ಬರೀಬೇಕು. ಅದಕ್ಕೆ ನಾನು ಮತ್ತೆ ಬರೀತಿಲ್ಲ. ಸೊ ನೋಟ್ ದಟ್ ನೀವು ಬರೀಬೇಕಿದ್ರೆ ಮತ್ತೆ ಬರ್ಕೊಂಡೇ ಬರೀಬೇಕು. So 3 plus 2 root 5 equal to a by b. What is a by b? B not equal to 0. A and b are co-prime integer. We can take 3 in right hand side. So 2 into root 3. Sorry. We can take right hand side of 3, but 3 is a plus form. So in right hand side we get negative. So 2 into root 5 equal to a by b minus 3. Again take 2 on other side. A by 2b minus 3. Take LCM on right hand side. A minus 6b by 2b. We can observe that we know that root 5. We know that in last problem root 5 is a irrational number. We know that root 5 is a irrational number. What is LHS? But we observe RHS. A minus 6b by 2b is in the form of a by b. A by b form is a rational number. So irrational equal to rational is not possible. So our assumption is wrong. What is our assumption? Our assumption is 3 plus root 2 root 5 is a rational number. But we get not equal. So our assumption is wrong. So next one, third main first problem is prove that following are irrational. Same method 1 by root 2. This is also very short answer. Very short andre short. In this question we get answer only 2 step, but we must write. Take contradiction method. Let us assume that 1 by root 2 is a rational number. So what is rational number? 1 by root 2 equal to a by b form. B not equal to 0 and a and b are co-prime integer. Take reciprocal on both sides. In any problem is given, we use this method also. We use this method only, students. Take reciprocal on both sides. We get numerator to denominator to numerator. We know that root 2 is irrational number. But b by a is in the form of rational. So both are never equal. So our assumption is wrong. 1 by root 2 is a irrational number. That is the proof only. So next question is second one, 7 into root 5 is a irrational number. Same method, 7 into root 5 equal to a by b. B not equal to 0. We take left hand side. We take right hand side for this number. Root 5 equal to sorry there is a mistake So sorry, a by 7b. Again we know that root 5 is a irrational number, a by 7b is a rational number. So we both, this is the 2 marks question, important question. So next, so we observe that 7 into root 5 is a, there is the step by step statement is there. Step by step statement is very important questions, friends. This is the exercise 1.2 is very much important for this chapter. So dear students, so if you want to like my videos, please subscribe, please share, please give me like. So then there is a last problem, 6 plus root 2. There is the last problem for your chapter, 6 plus root 2. So we can take not only a by b, we can take x by y also. Y not equal to 0, x and y are co-prime number. So ನೀವು ಯಾವ ನಂಬರ್ ಆದರೂ ಚೂಸ್ ಮಾಡ್ಬೋದು. x a by b, p by q, x by y is on only form of the a by b form. So 6 plus root 2 equal to a by b, we take 6 on right hand side. So x by y minus 6, take LCM, x minus 6y by y. We know that root 2 is irrational number, but x minus 6y by y in the form of a by b. A by b, which number in the form of a by b is called a rational number. So irrational number is never equal to rational number. So dear students, please watch my full video. Suppose you have to like my video, please subscribe, comment me, like me and share me. Thank you for watching. This is my first teaching video. Please support me.